Okay, it seems it is actually recording. Yes, yes. Okay, we are going to transfer the theoretical knowledge you have acquired with Professor Coppola during the previous lecture in practice using visum. And we're going to explore specifically 3 blocks. So basically our lecture today is divided in 3 blocks. In the first one, we're going to explore the study area, the zoning, the centroids, etc., etc. And also we are going to perform some territorial and socioeconomic analysis in order to understand how our study area is composed. And I will show you exactly how to do that in visum, and you will have the chance also to practice a little bit on your own. And I will assign you some specific tasks. In the second block, we are going to explore the demand, so the OD matrix, and I will tell you how to visually analyze an OD matrix. You've seen with Professor Coppola that an OD matrix is basically a matrix containing numbers, but it is always good to perform some visual analysis in order to provide some information and to visually extract some information from a mathematical tool, the OD matrix. And in the last part, we're going to explore the transportation supply. So basically, the road network, because in this exercise, in this transportation modeling practice, we will do only with the private transport. So trips by car moving in a road network. We are not going to consider public transport. Then, in your project work on transportation planning, depending on the project, you will have also the chance to play a little bit with public transport modeling. But bear in mind there's a specific course next year, public transport management, where PDV visum will be used to specifically model public transport. To summarize, we're going to touch everything you've seen in theoretical lecture. Preliminary concept, study area, zoning, etc., and also territorial analysis. Second, demand. Third block, supply. We are not going to see today the so-called demand-supply interaction assignment models because you haven't seen them in the theoretical lecture. Once you will see the assignment model with Professor Coppola from the theoretical point, I will show you how to perform the demand-supply interaction using PDV visum, okay? Now, I would love to invite you to go to the WeBIP channel. There's a folder named TMP and PW, that are basically the acronym of Transportation Modeling Practice and Project Work. That, if I'm not mistaken, is folder D. I will start sharing my screen so you will be... Okay. Here it is, the screen from the WeBIP, right? In folder D, you will have the chance to see that I've uploaded for the transportation modeling practice 2 files. First, download them, and then second step, please create a folder, a specific folder for the transportation modeling practice in your desktop or wherever you want. Now, the thing that is important is that you will insert both files in a specific folder somewhere in your personal computer, okay? In the meantime, I will explain you the meaning of these 2 files. You will find a file that is called BER, or basically its extension is .BER, and you will be very, very familiar with this type of files because are the base version files of PDV visum. Meaning that every time you want to launch a specific project in PDV visum, you have to just simply refer to the project, to the BER file, double click on it, and PDV visum will open exactly this project, okay? The second file is study area. It's called study area. And its extension is a GPA, graphic parameter file. That is basically a way to save visual display maps in PTV Visum. Okay? Please download them and insert them in the same folder. Okay? After doing this step, just simply double-click on the BER file, TMP V00 base, to open PTV Visum. And here it is. The screen you will. Does anybody of you is actually having problem in opening it? Maybe require a little bit of time to open the software, to launch the software, depending on the computer, and depending on its power, its velocity. But basically, this is the visualization you will see once the file, once the project, once the BER file, the .BER file is downloaded and opened. All good? It's all good, guys? Is there anyone experiencing troubles in this first preliminary and very, very easy step? No. Okay. The second thing that I want to say to you before to start is that most of you have downloaded PTV Visum and have experienced travel with languages. A little bit German, a little bit Italian, a little bit English. It depends on the computer, it depends on the version, etc., etc. Now, I will encourage you to set the language to English. Just simply go over here in the Edit button, top left, Edit button, and then go to User Preferences. Just simply select here as primary language English, as fallback language English. Okay? So, once again, just simply go to Edit or Modifica, in case you have it in Italian, User Preferences, English. Okay? Person? With your license?
Yes.
You haven't activated yet?
No, I haven't activated it, but it seems it has gone back to basis, but I don't want to mess it up.
Okay, let's do it in this way. What's your name? Ricardo. Do you have a PTV Visum on your computer?
Yes.
Okay, so for now, just simply use this computer, and then during the break, I will tell you how to solve it. Okay? So the first basic step: how to modify the language, edit, user preferences, English. Okay? So from then on, you will have the chance to have your PTV Visum in English. Okay? Now, is there any one of you experiencing some troubles in looking this screen? No? Hope not. Okay. One thing, just as a check, that I will love to see is if you go here on graphic parameter files, the button highlighted in yellow, you should be able to see, if you click on that, the GPA file 01 back study area. Is it correct? Yes. Okay, very good. Now, the only thing that is different in this exercise between you and me is that In the graphic parameter files folder, this one over here, I have several files, okay? And I will show you how to save them, how to produce them during the exercise that we're going to do together. So I've prepared them basically last night, and I will show you how to populate. But if you click on that, the graphic parameter folder, you will see only the first GPA, the first graphic parameter file, that is study area. And I will start creating with you all the other files. In case you want to have exactly the same visualization that I will show you, I will constantly upload them in the WebIP folder. So at the end of this lecture, hopefully we will find all these graphic parameter files uploaded in the WebIP folder. Now, let's look a little bit PDB visum and how it is composed. This is the so-called network editor. In this block, you will find all the things, all the database from a geographical viewpoint. Basically, as said during the previous lecture, PDB visum is based on a GIS, and here it is the output, the final GIS output, visualization. Then you will have here some information related to network. If you go here in matrices, you will have the chance to see all the matrices stored in the software, or that can be calculated using the software. But for now, let's stay a little bit on the network editor, and particularly to all the comments we have here. Now, if you start scrolling up and down using your mouse wheel or using this button, basically you will see that there are some elements, some objects that are a little bit tricky for you, something related to public transport, such as stop points, etc., etc. But you will also see some names with which you are a little bit familiar. For instance, zones. Here, once the study area is identified, I would love to start the zoning process to visualize zones. Then what I have to do is just simply create and select my base network, my base road network that should be consistent with the zoning, and basically the zone network is composed by nodes and links, right? Okay. We will touch everything about all the objects you've seen in theoretical lectures. For now, we will start from the study area. That is this one, okay? The one highlighted in red, orange, something like that. A little bit of transparency. It should be orange or something like that. Okay. Now, once the study area is identified, the second step is that of performing a zoning process. And the zoning process in this exercise has been already performed by myself. The only thing that we have to do is just simply visualize it. Now, how to visualize zones and how to customize the template of visualization for zoning. Every time you want to visualize something, every time you want to customize something from the graphical viewpoint, you have to first select the object you're referring to, right-click, and edit graphic parameters. So once again, please select the object, zones, right-click, edit graphic parameter, and this window will appear, okay? I will encourage you now to double-click on the draw surfaces to go in the lower part and select border color. Let's assume the border color is red. You can put the border color you want. It's not important. It's just a visualization thing. Okay? Now just simply click on OK. And OK. And here it is the final output, the zoning process performed. Okay? Once again, these are very, very basic steps, and I promise you will be definitely really familiar. This is something for those of you that are, I would say, GIS expert or that experience GIS a little bit. These are very, very trivial steps. We are dealing only with visualization. Every time you want to visualize something, and in this case, I want to visualize zones, just simply select zones over here, make sure that zones is active, and the icon related to zone is active as well. Right-click and edit graphic parameters. Okay? Now, here, what you have to do to visualize zone is just simply modify a little bit the draw surface and select the border color. Border color, in this case, red. Okay? If you start clicking OK, OK, you will have this output over here. Good? Okay. Now, as said, I created it yesterday evening, and I have already saved it to my folder. So I have my graphic parameter file saved. How to save a graphic parameter file? Just simply go over here, click on graphic parameter files, and here you can go to the add button if you want to save a certain visualization. Okay? You can try to do it. If you have arrived through this visualization over here, is there anyone experiencing problem in arriving to this phase, I would say, to the zoning? Yes, no? No, okay. Once you arrive to that, if you want to save it, because it's important to recall at a certain time, I would love to go back, etc., instead of saving the BER file, so instead of traditionally save this BER file, you will have the chance only to save the visualization, only a map visualization, okay? How to do that? How to do that? Just simply go to graphic parameter files and click add. If you're going to click add, you will be able to save something. You will be able to rename it as you want, for instance, 0.2 /zoning, and save it clicking on the green button. Please.
Yeah, I have a question about visualizations. If we add some extra data and we already have some visualizations and that data change, like the main shape or whatever, everything's gonna change?
Yes.
Or, okay.
Okay, it's a very good question, thank you. So, the point is, I'm actually saving something that is relevant from the visualization and communication viewpoint. So, I'm basically saving some maps. I'm telling Visum, well, if you have to visualize zoning, I would love to visualize zoning in this way, with these colors, with this border, etc., etc. And I'm saving it as a graphic parameter file. Now, if I will update my data, if I will start creating here a new zone, the visualization will be updated as well, okay? The visualization will consider all the data stored in PTV Visum, okay? Good. Now, I have created it, as said, last evening, so basically a little bit modified, this one, and I will upload as promised in the WebIP, folder. That is the zoning graphic parameter file. That is the one that we have created. Now, if you want to see exactly the visualization I have on my screen, just simply go to the Weebit channel, download the zoning graphic parameter GPA file, .gpa, and put it in the same folder where you have the BER file, the folder you created at the beginning. All clear? All good? Is it good? Nice. Very, very easy. Now, some of you oops, sorry. Some of you noticed the fact that I have, apart from my visualization, also the legend. It is very, very important to have a legend just to communicate people what actually I'm visualizing. How to customize a legend. Here it is the button you have to click on to customize your legend. Here it is, the Edit Legend button. I'm not going to spend time for legend customization. This is just to say that every time there's something bad here, there's something that should be modified, just simply refer to this button over here, Edit Legend. If you click on it, a new window will appear. You will be able to select data to be inserted in the legend. You will be able to customize, just simply moving to other pages in this box. You will be able to customize the legend, to customize the text, to reduce the size, to change the layout, the font, etc., etc. Okay? Everything regarding the legend can be done here, exactly this button over here, Edit Legend button. Okay? Good. Now, every time you have a zoning, and every time a zone is created or is uploaded in PDD visum, you should have also the so-called centroids. Because bear in mind, we start from a continuous space, we decide to subdivide it in different zones, and we associate to each zone a fictitious node, a single node, fictitious node, where all the trips starts and end. How to visualize centroid? First, you have to have in mind that from the theoretical viewpoint, centroids and zones are strictly connected. So I have to modify something related to zones. Right-click on zones and edit graphic parameters. The process we did before to create zoning. Now, please play a little bit with this box over here, that is the text box. And please increase the size. Let's do it to 1.5. Please deselect the box transparent. Please select black color. And that's it. Okay? So something like this should appear. Of course, you don't have to reproduce exactly the same visualization I do, and I did using visum. You can customize it, you can use different colors, different font size, etc., etc. The point here is we are actually trying to move from a zoning, no better to move, to start from a zoning system visualized. We would love to see also centroids. We would love to see also these fictitious nodes in our study area. You will be able to modify this box over here. Just simply click OK. And you will find a zoning process plus some labels in my study area, some numbers in my study area, and I will tell you each number corresponds to the zone number, and this number should be interpreted as centroids. If you scroll, if you zoom in, for instance, a little bit, just simply explore the map having the edit mode, the arrow activated. Just simply select this one over here, this zone over here. I've selected the zone 600, but no matter. These are zone boundaries, and this is the fictitious node, the centroid, related to that specific zone. Okay? Is it clear? Now, before moving to the next step, what I said to you is that basically you have zone boundaries highlighted in red in this visualization, but you also have numbers representing centroids. Some of you may have noticed the fact that there are some others nodes, some other centroids having no zone boundaries associated, okay? This is exactly the distinction between centroids internal to the study area, internal centroids, and external ones. Could some of you please recall me what is the theoretical reason why we insert these external centroids? We take our study area, we subdivide it in zones, and each zone has associated its fictitious node, the so-called centroid. But we also insert in the modeling phase some external centroids. What is the reason for inserting some external centroids in a study area, in a model, sorry? Yes, to capture the behavior outside the study area. It's not perfect. I mean, it's going the sense of the final answer, but it should be refined a little bit. The thing that should be refined is we are not interested in the behavior outside the study area. We are interested in the interaction between outside and our study area. How the outside world affects our study area. How the behavior, in this case of drivers, moving from outside the study area to inside, or just simply crossing our study area, how that behavior affects our study area and the impact on the study area that could be impact like congestion, road congestion on our study area. Okay? Is it clear? Good. Now, one thing that we used to do in order to visualize things better is just simply divide or visualize differently the internal centroids and the external ones, just to visualize things a little bit differently, and to divide this theoretical concept also in a map. Now, how to visualize things differently? How to visualize centroids differently, depending on the fact that they are external or internal? Just simply right-click over here and edit graphic parameter. So zones, once again, right-click and edit graphic parameters. Now, here the point is, I want to visualize the same object, centroids, zones, in two different ways. External centroids with some colors, internal ones with another colors. You have to move from the uniform display, that is a PDV visum function allowing me to visualize things, the same object in the same manner, to a more advanced display, that is the classified display. So just simply click over here to open a new visualization scheme provided by PDV visum. This classified display allows you to visualize the same object, in our case centroids, but in two different manners, or in 3, 4 different manners, in this case 2 different manners. We would love to have some colors for internal centroids, some other colors for external centroids. Now, this is something that I would say to you. The external centroids in your model are classified as, sorry, the internal centroids in your model are classified as type number 1. Instead, the external centroids are classified in your model as type number 2. This is my assumption, the assumption that I did last evening, but you should be very, very flexible. I mean, once you will move to another model, it's not obvious having the same field, type number, meaning exactly the same things, internal and external. This is valid only for the model you are using for the transportation modeling practice, okay? So, how to visualize differently internal and external centroid? You have to select the attribute type, type number, 1 if it is internal, 2 if it is external, and then click on the button Redefine All Classes. Every time you have to deal with a classified display, you have to use this box over here, Redefine All Classes, to first select how many classes do you want to visualize. In my case, 2, number of classes, and just simply click OK. I know this is a little bit boring, but the point is, in this very first step, is that of familiarizing a little bit with PDV visum. Then you will do all of this stuff. I promise you, you will be able to reproduce today's lecture, or at least the first part, in 5 minutes at the end of this course, okay? Because you will be very, very familiar with the software. You will be also able to customize a little bit the text. Just simply go on Preview here, double click, and let's assume to modify those having type number 1, so internal centroids. Let's assume I would love to visualize them in red. So text in red, but also the frame in red. Okay? If you click on OK, you have modified something here. Now, if you click on Preview, you will see the preview of your visualization. I know it's not perfect. I know it could be refined. I know some of you may like red, some others may like blue, etc., but the point is I've used a classified display to visualize the same object, centroids, in 2 different manners, depending on it is external or internal. And in this case, I have red internal centroids and black external centroids. Is it clear from the practical and the, I would say, not the theoretical, but I would love to know if it is clear, the overall flow with it, okay? Because no matter how much time do you need to produce a good visualization, as said, I've done it yesterday evening, and I've done something that is probably a little bit better than the current visualization. So I will upload on the Weebib channel the GPA related to zoning with centroids. If you want to have the same visualization I will show you, just simply go on the Weebib channel, download the zoning with centroids GPA, graphic parameters file, and please put it in the same folder where you have the VER file, the .ver file that is our PTV Visum project. So, if everything has been done correctly, that file will appear here in this list, the same list we explored before. So once again, just simply go on graphic parameter files, click on zoning with centroids, and here it is, the visualization that I did last evening. Even though I was a little bit tired, I think I produced a better visualization with respect to that I proposed to you this morning. So just simply use this one as base visualization for zoning plus centroids. Particularly, centroids are divided in two types. On the one side, we have internal centroids in black. On the other side, we have external centroids in blue. Okay? All good? All clear? Do you have any questions till now? Yes, no? Let me see a little bit the chat, just to be sure I'm not missing anything. There is the chat. Okay. No questions in the chat. Very good. So, we can now move to do something more practical. Particularly, we are going to perform some territorial analysis. Bear in mind that we will use several synonyms for the same things. We would love to understand how the city is composed, what is the structure, where people live, where people work, where the concentration jobs mostly concentrated, etc., etc. We used to call it territorial analysis or socioeconomic analysis or context analysis. You can use all these words as synonyms, okay? How to do that? You have to import in PTV Visum some data related to the attributes you are interested in. And last week, if I'm not mistaken, or 2 weeks ago, we've seen that every time you need territorial data related to a study area, you have to refer to the statistical, to the National Statistical Institute related to the country. ISTAT for Italy, Eurostat for Europe, etc., etc. In this case, given the fact that we took as example a small German city, not so far from Leipzig, that is called Halle, we referred to the Eurostat website or to the German National Institute. What I did for you is that of downloading data and importing this data in PTV Visum. So this is not an automatic process. I mean, if you open PTV Visum, a new project from scratch, you won't find data. You have to upload the zoning, you have to define which data you are interested in, and then you have to refer to an external website to query this data, to download this data, and import them in PTV Visum. Here the point is where I can find and where I have to upload this data. PDV visum is a GIS database. The GIS database, so the thing that allows you to visualize real things on a place, on Earth, on a map, is this box over here, so the so-called network editor. This is the visualization part, but behind it, there's a normal database. Every time you want to explore all the data that are stored in PDV visum, you have to open the so-called list button. List button over here, top left, between view and filters. If you click on that, you will be able to see all the objects that are included in your PDV visum project. In this case, given the fact that I would love to perform a territorial analysis, I'm interested in zones. Each zone is, of course, represented with a centroid that is a fictitious node, but in my database, I have also some data related, for instance, to jobs, to population, etc., etc. Now, if you want to explore the database related to zone, just simply go on list, network, and then zones. Once again, list, network, and zones. If everything is correct, this window will appear. Basically, a normal database, okay? In this case, we have each row representing a zone, each column representing an attribute related to the zone. Particularly, in this visualization, we have the so-called NO, that is the zone number, and you will see we have 71 zone numbers. So in our model, we have 71 centroids, 71 zones. Of course, these are divided between internal and external centroids. We have the zone name. Sometimes it's populated, sometimes not. We have the type number. Once again, this is 1 if it is an internal zone, so an internal centroid, and 2 otherwise, so if it represents an external centroid. But we have also other attributes, for instance, jobs industry, jobs retail and job services, and jobs total. What does this represent? Of course, jobs total is the number of jobs, the number of workplaces I have on a certain zone. For instance, in zone number 40, I have 2,300 approx workplaces, 2,300 approx jobs. But these jobs are subdivided in jobs related to industry, jobs related to retail, and jobs related to services, such as municipal services, postal services, etc., etc. Okay? One thing that I've also uploaded, and specifically I've asked to PDV visum to calculate, is the so-called job density. I'm not interested in the absolute number, or better, I couldn't be too much interested in the absolute number of jobs, but rather in the density of a certain attribute, in the density of jobs. And here it is, the job density. The same goes for population. In this model, I have uploaded the population TOT, the total population, but I've also segmented it into workers, students, and others. as I did for jobs. I've also calculated population density, or better, I've asked the visum to calculate the population density. And basically, I've established a very simple formula saying, well, for this zone, the population density is the population living, the total number, divided by the square kilometer of area related to the specific zone. Please.
Does these attributes has different characteristics? I mean, for example, there are some that are just for text, there are some that are just for numbers, or I can use any data in any attribute.
You can use all the attributes type you want.
Okay.
You can use integer, number, text, categorical attributes, floating, etc., etc. No matter the attribute type.
Okay.
You can insert the attribute in which you are interested in the format you would love to have these attributes.
Okay, awesome. For example, if we have different kind of characteristics in each attribute, and I want to perform something, is the program going to show me an error, or it's going to just take the information that they can run?
Could you please give me a sort of an example?
For example, I have a column with, I don't know, job numbers.
Yes.
But how the data, instead of numbers, has, I don't know, a letter or something like that.
Okay, I see. Yeah. Of course, it depends. You can insert data as number or letters, so text or integer or floating, depending on the scope of your analysis. If you want to ask visum, for instance, to visualize a graph related to the population distribution by students, workers, and others. So a pie chart or a column chart as well. Of course, you will probably need numbers. Instead, look at this case. We have also an attribute that is related to name. Okay? If you are interested in visualizing a label related to each zone, so just to communicate to other people the name of that specific zone, well, you can insert this attribute as text. It depends a lot on the type of on the things that you want to communicate. Okay? I'm not sure I fully covered everything, but we will continue. Do you have any question on that? No? Okay, let's assume I want to, I'm not too much interested in all of this stuff. Let's assume I would love to focus only on population. How to modify this visualization? You have to go on this button over here. The so-called select attributes. If you click on that, a new window will appear, and you will be able to modify the attributes in which you are interested. Just simply, if you want to add something more, you have to go here and start searching. If you do not remember the name, if you are a little bit unsure about the name, but you would love to search something, just simply go in this box over here, scroll up and down with your mouse wheel to select the attributes in which you are interested. Once you have identified it, let's assume I'm interested in population other, use this arrow to insert it in the visualization. Okay? Given the fact that I've inserted 2 times, and I don't want to see a repetition in my database, I can simply select it using the arrow, the opposite arrow, to remove it from the visualization. This is only a visualization matter related to the database. Okay? Okay. Now, moving back to our objective. Our objective was that of performing some analysis related to the study area, to understand where people live, to understand where people work, to understand the breakdown by workers, students, and other, or the breakdown by type of jobs, industry, retail, or services. How to do that? Just simply feel free to close the list related to zone, or just simply to move back to the network editor. Okay, you can maintain that window open or not, it's up to you. Just simply go to the network editor. Now, the first thing that I would love to do is that of visualizing the attribute population density. Okay? I can anticipate to you that, of course, this attribute population density is related to zones, and of course, I would expect going here to zones, right-click, and edit graphic parameters. Okay. The second thing that I would expect is that I would love to perform a map that, if it is uniform, doesn't communicate me anything. I would love to visualize a map related to the population density and the distribution of population. So the display that I will use, that I have to use, will be the classified display. So right-click on zones, before that, instead of starting from this visualization, just simply click on graphic parameter file and just simply go back to the zoning GPA. Okay? So I have quick access to the previous visualization. And from that, I will start inserting something. I will start visualizing the population density. Now, right-click, edit graphic parameters, and select classify display. In the classify display, basically visum is asking me what do you want to visualize. In this case, I'm not interested in type number. I'm interested in the attributes population density. Okay? So just simply click on the pencil here. Click on the pencil here to select the population density attribute. That is called POP density. This one over here. Double click to select it. So what I'm performing is a classified display related to zones for population density. Now you have selected the attributes. You have to customize a little bit the classes, etc., etc. So go on refine all classes button. And here there are some things that should be modified. Particularly, we have to define in a classified display the number of classes we want. In this case, let's assume we want 5 classes. Now, every time you create classes, you have to have in mind that classes, in order to visualize a continuous attribute that is population density, needs to be defined according to some class boundaries. Okay? Class boundaries in PDD visum can be calculated here using several algorithms. You can use a user-defined, not an algorithm, a user-defined class boundaries. So if you click on user-defined, you will be able to modify all of these class boundaries. You can use the equidistant algorithm, defining a step between class limits. You can use logarithmically distributed algorithm, etc., etc. My suggestion for you is that of not losing too much time in understanding which is the best algorithm that I have to use, etc., etc. Depending on the type of data, PDV visum can provide you the so-called the natural breaks visualization algorithm, trying to define class boundary in the most efficient way, according to him, according to the software, in order to perform a good visualization. So, if you click on natural breaks, you will have as output class boundaries already defined by the algorithm. Okay? Now, given the fact that the final output of these analysis will be a map that should be interpreted, a map that should be interpreted by us, we are all engineers, by technicians working for certain companies, also by politicians, etc., etc. And in general, also by non-expert people, the map should be very, very simple and very, very effective in order to communicate efficiently. One thing that I want to say is something I would say not too much in line with the lecture, but a suggestion for you is bear in mind that no matter the technical analysis, this will count at the end of the story 30, 35%, and will be 35% of your job. 70, 65%, it depends, will be only good communication. So if you are very, very good with number analysis, etc., etc., but you are not able to communicate effectively, you will lose, okay? It's very, very important, this lecture, at least the time we are going to spend together in this first part, because you have to spend a lot of time in communicating things effectively. And I will expect at the end of this journey together, this 3 months journey together, when we are going to present your project work on transportation planning, your technical analysis, etc., etc., and bear in mind the final output will be a PowerPoint presentation to be discussed with the professor, with the company representative, etc., etc., to have a perfect, a wonderful PowerPoint presentation to communicate effectively your narrative, your story, your path during this course. So please, guys, do not ignore effective communication. On the one side, verbal communication. On the other side, visual communication, okay? That could help you in achieving your objective. That could be that of providing politicians different alternatives for certain projects, or convincing someone that the good strategy for sustainability is the one you're proposing, okay? So, going back, apart from natural breaks that allows you to define class boundaries, of course, natural breaks is an algorithm that gives you an output, some weird numbers. Now, try to imagine a non-technician looking at these numbers on the legend and saying, class boundary number 1, all the zones that have population density lower than 589. 589. I'm losing it a little bit in 589, okay? Let's do things a little bit simpler than they are, easier. So, after performing a natural break, just simply go on user define and select, just simply round a little bit this number. This is something obvious. This is something really obvious, but I promise you it is really important in effective communication. So first class, instead of 589, let's assume it's 600. The second one is 2,000, sorry. The third one is 4,000. And the fourth one is 7,000. Okay? Now, in order to communicate things effectively, what you have to do is to just spend a little bit of your time on colors, a little bit of your time. I know we are all engineers, so we would love to, I would love to spend all of my life using R, Python, programming, etc., etc. Maybe some of you have some other interest, but at least for me. Okay. Let's do not open this stuff. Okay. Try to spend a little bit of your time on colors. We are trying to communicate effectively the population density. What is the scale of color that you expect? No matter the color, but I would love to have something darker, where I have higher population density, something lighter, where I have low population density, okay? This is something obvious, but please remember it, okay? So, if you click on this arrow, the one pointing to colors, you will be able to select some colors, predefined color scales, okay? Predefined color ramps. And let's use the first one, from white to yellow to orange to red. This is exactly what we want. For smaller values, we have white, and for higher ones, we have red. Okay? Good. I think we've done more or less. Just simply click on OK. And finally, to test our visualization, let's click on Preview. Now, I think some numbers that are a little bit boring. For instance, the centroids related to zones, so the labels related to each zone representing each centroid. To erase them, just simply double-click on the preview here and put the text to 0. Text size to 0. You have to repeat it 5 times. Once repeated, click on OK, and here it is, the final map we have. Okay? This is the map related to population density. Now, before the break, we can spend 2 minutes on interpreting this map. What is your interpretation of this map? How to interpret this map?
The city center is most desirable of all, but there's a certain area on its left, the industrial area or something like that, where many people can
work. So, the point is, I would love to interpret my city. The first thing that is clear is that where it is darker, I have more population living. The population density is higher. So, looking at this map, I can read my city in this way. Well, in the city center, it seems that a huge population density. Not only in the city center, there's an area over here that could be a residential area, according to my data. This could be a residential area. Apart from that, looking at the lighter value, looking at white, so at the first class, where the population density is very, very low, there's an area over here that, in terms of population, it seems quite empty, okay? Maybe, I don't know, I have to prove it, maybe this is an area related to industry, services, etc., commercial area. Let's see. But there's an area that is quite empty in terms of population living there. And we can suppose it's an area related where there's a business district, industries, etc., etc. This is something that we have to prove, and we will see if you, what is your name, please? If Filippo is right, your interpretation is right or wrong, making some other analysis related, for instance, to jobs. Okay, we will start doing this stuff in 15 minutes. So I will propose a 15 minutes break, and we will start again at 5 to 12. Okay? Thank you, guys. Recording is activated. Nice. I have uploaded on the Weebip channel the GPA file, the graphic parameter file related to population density. I'm not showing the GPA file related to job density. So basically, I will upload it right now in the Weebip channel. Let me see where it is. Okay, I have uploaded it on the Weebip channel, so please download it and open it with me. Basically, I've performed the same classified display for two different zonal attributes. On the one side, population density, this visualization over here. On the other side, job density, exactly the same visualization, but visualizing another attribute. The job density is the GPA file uploaded on the Weebip channel, number 606 job density. If you open it, you will be able to visualize something like that. Okay? Questions? Are you experiencing problems in opening? Please.
When are we, like, if we edit this current view, are we editing the GPA file? Or it's like whenever we, like, already say?
Okay. If you modify this view, let's assume you decide to focus on the city center. Instead of having blue colored zone, let's assume the last one, instead of being blue, it's red, okay? I know it's a weird visualization, but it could be a visualization. You're not saving anything. If you want to go back to the GPA file, so the file that you saved, you have to simply go here and click on job density. If you click on job density, everything will be restored to the GPA you saved. Now, if you want to save this visualization, just simply click on graphic parameter file and click add and customize your title. It could be job density modified with red, okay, to save this visualization. But in principle, you are not modifying anything. If you want to go back to job density, the one with all the blue scale, just simply go back here, and here it is. Okay? Am I answering your question? Good. As said, this is the job density. Now, focusing before on population density, well, Filippo said, it seems there's a residential area over here, but also the city center is really populated. This part of the city, the right one, seems quite empty. Probably, we don't know. It is an area that is an industrial area or commercial area, something where there are several workplaces. and you are able to prove this or not if you move to the job density map. And here it is, the job density. Basically, Filippo, you're right. Here it is the zone we were referring to, and we are actually seeing, using this map, that this zone is a zone full and rich of workplaces, okay? We can also see the opposite. Basically, this area over here was a residential area where several people live, that is actually quite empty in terms of jobs opportunities, okay? So we can say, well, this one over here is a residential area. This one over here is a sort of commercial or industrial or another area where a lot of jobs are located. This is the city center. And now, my question for you is, given the fact you are mobility engineers, and the final objective is that of simulating the behavior of people, let's assume this model is a model with the aim of simulating the morning rush, the morning peak hour time span. What would you expect? You want to say something or not? I see your hand doing something like that. Okay. Left to right, probably, we don't know, but this is something that we can expect. So we can expect in the morning peak hour, in the morning rush, that is our time span of simulation, several people starting from this area over here, that is the residential area, and going through this area over here, that is a commercial, industrial, no matter, an area where jobs are located, because they want to go there for working purposes, right? Of course, this is a behavior that we can expect. It's not the only one, because probably there are some area where a lot of students are located, and instead of going to a commercial or industrial area in the morning, they want to arrive at the university or schools, etc., etc. But the point is, with this territorial and socioeconomic analysis, we are able to understand a little bit how the city is composed, okay? We've seen together the so-called classified display for population and job density. Let's assume I'm interested in understanding the city a little bit better. I want to go a little bit deeper on my analysis. Instead of seeing an aggregate number related to the total population, I would love to understand the breakdown by zone of population students, population workers, and population others. The first thing that I have to do is that of having these attributes stored in my database, and I've seen them in my database in PDV Visum. Just simply go on list, network, zones. As I've seen before, I have not only the total population, I have population other, population students, and population worker. The point here is, with a classified display map, we are not able to visualize more than one attribute. With this map, we are able only to visualize one attribute. That could be population density. Now I could decide to, instead of visualizing population density, to visualize population students, population workers, population others. But I could also visualize more than one attribute, moving from a map to a map containing some graphs. Okay? It will require a little bit of time. I'm not showing you all the details for creating these graphs. I will upload through the Weebit channel of the course the graphic parameters related to both the column charts and the population. Let me just give me some minutes. Here it is, population chart, and here it is, jobs pie chart. Okay, I have uploaded them through the Weebit channel. Basically, I encourage you to download both of them, and we will explore a little bit the difference, and I will briefly tell you how to create them. So, in case this will be useful for your project work on transportation planning, you know what are the visualization, the views, and the comments you have to refer to create specifically this visualization. Now, if you download it and put them in the folder where you have your VR file, the GPA 05 population column chart will appear. Okay? I will tell you first the meaning of this chart, and then I will show you where you have to go to visualize it. Basically, the meaning of this chart is that of having a column chart, each one related to its zone, and visualizing in a column the number of workers in yellow, the number of students, and population others, so others than students and workers, in blue. Okay? Very, very easy. Now, how to perform this display? Just simply right-click on zone, edit graphic parameters. Instead of focusing on this box over here, you have to just simply go to chart. Okay? Chart button over here. Just simply feel free to select it. And there you will find the view in order to customize the chart in which you are interested. Okay? Is it clear? I won't spend too much time on that. The point is, it's only visualization matter. You feel free to play a little bit with graphic parameters to see if I modify the scale, if I move from a column chart to a pie chart, etc., etc. Feel free to play with this visualization. I will close this window. Instead, just for sake of completeness, I will show you also the other graphic parameter file that I've uploaded on the Weebit. That is the job pie chart. Okay? Here it is, another visualization. Of course, the higher is the radius, the more is the number of total jobs. This is a pie chart, a traditional pie chart, representing a breakdown by what? Yellow, we have a percentage of jobs related to industry. Green, we have a percentage of jobs related to services. Blue, we have a percentage of jobs related to commerce, retail, etc., etc. Okay? This visualization could be useful for your project work on transportation planning. Of course, if you want to customize this visualization, what you have to do, given the fact we are displaying zonal attributes, just simply refer to the zones. So, right-click on zones, edit graphic parameters. If you are interested in charts, just simply select charts over here. And from there, you are able to customize everything. You are able to scale the radius if it is too big or too small. You are able to insert some labels, as we did for column charts, not having only a pie chart, but a pie chart plus labels, and so numbers to be visually communicated, etc., etc. Feel free to play with this visualization. Now, I want to move from this first part related to the socioeconomic or context or territorial analysis to the second blocks that is strictly connected. Because what is your name, please? Stella. Selan. Selan. Okay. Selan said before that starting from the distribution of population living in our study area and the distribution of jobs related to a study area, we can expect a sort of a behavior. Some people in the morning rush moving from left to right to start from their place, from the place where they live to the place where they work, probably. So basically, this implies that the distribution of population living in a certain area and the population working on certain other areas generates demand. And you've seen with Professor Coppola that the transportation demand is a derived demand, derived from user needs. I wake up in the morning, I will start from Porta Genova, arriving here in Bovisa for working purposes. Maybe you will start from other origin, arriving here for the same purpose, working study purpose, right? Okay, so I want to open a second box, that is the box related to the demand, because for now we have seen only the socioeconomic context and territorial analysis. Every time you refer to the demand, you refer to a mathematical model of the demand that could be a 4-step model that is actually not implemented in this exercise, but some of you, depending on the project work topic, will deal with the full, complete 4-step demand model in their project work. Even though not implemented, we have uploaded in the matrices folder a matrix containing, an OD matrix containing trips by car. So we will simulate in this transportation modeling practice only trips by car. Where this matrix is stored over here. You have to move from network to matrices. If you go on matrices, you will be able to see all the matrices that are imported or calculated by PDB visum. At this stage, we haven't calculated any matrix. We have just simply uploaded a demand matrix that is the demand related to trips by car, okay? The name of this matrix is called 100. It is just simply a code. This 100 does not refer to any trips or stuff like that. It's just simply a code of PDB visum. 100 car. This is our OD matrix of trips by car. Double click on it. First, how many rows do we expect for an OD matrix? 71 in this case. That is what? The number of zones, no matter number of centroids, no matter if they are external or internal. These are 71, that are the number of zones. How many columns?
Depends on attributes.
How many columns? 71 as well. We have an OD matrix representing all the trips from each origin in a row to each destination in a column. One thing that I would love to recall you is that no matter the number you will see on the diagonal, this could be 14, or this could be 0, or this could be 200, no matter the number of the diagonal. In the simulation, we are not accounting intrazonal trips, so trips starting and ending in the same zone. Trips starting and ending from the same centroid. This won't affect the results. So the diagonal elements, those highlighted in yellow, won't affect the results of the simulation. Let's assume this value over here. From zone number 120 to zone 14, I have more or less 10 trips. Why do we have a decimal place? Decimal place, even though for some of you could make no sense, because what does it mean having 10.7 trips? Usually, given the fact that this OD matrix is calculated through a 4-step, we just simply apply the 4-step, copy and paste the results, and upload it to the software. So, if you will see decimal places, even though this makes no sense, it's mathematics. Okay? Don't be scared. You can interpret this result, 10.7, like 10 or 11, no matter. Okay? We are interested overall in the final simulation. Just simply to recall you something that should be very, very important for visualization purposes. If you're going to sum up all the elements in a row, and particularly all the elements in row related to zone 120, number 120, with the code, number code 120, we will obtain these results over here in green, that is the sum, that is 721 approx. What does this 721 represent? Any idea? The number of trips starting from that zone. In other words, the number of trips generated by that zone. Okay? The number of trips outgoing, we used to call them outgoing journeys, outgoing trips. Okay? The number of trips generated by that zone. For outgoing trips related to a certain zone, just simply sum up all the elements in a row. The other way around, what about a column? Let's assume we have zone coded as 80. Summing up all the elements in this column allow us to calculate this number in green. Visum do it on its own, that is approximately 700. What is 700? The attracted trips, the number of trips attracted by that specific zone, no matter where they come from. These are all the trips attracted from that zone, all the trips going to that zone. We used to call them incoming trips, incoming journeys. Okay? So, just to give you an idea, a good way of moving from this very boring table here, that is our odimetrics, to more simplistic visualization could be that of, okay, let's create two different maps. On the one side, I will have to calculate, I will have to visualize trips generated, so outgoing journeys. In parallel, I will do another visualization of incoming journeys, of trips attracted. These are two very popular and possible visualization of possible ways to move from this boring table to a map. Okay, please.
Does this number include the internal trips? Like the sum of these numbers include internal trips?
Not only internal trips.
No, I'm talking like you mentioned before that we don't show, like we shouldn't take in consideration the internal trip between zones. So since the program is showing us like the sum of everything, does this sum include the internal trips?
The internal, you mean the trips in the same zone, the intrazonal trips? Okay. Yes, is calculating exactly also that number, because from the mathematical viewpoint is summing up all the elements in a column, and if you arrive here in a column, you will see also the elements on the diagonal. Okay, so the summation includes also that. Okay, but in the final simulation results, the elements on the diagonal won't affect in any way the results of our simulation. Okay, so two possible ways to move from this very boring table to some more readable maps, that of performing a classified display related to trips generated, another classified display related to trips attracted, and so on the one side, outgoing journeys, on the other side, incoming journeys. The thing that we are missing is that if we are going to visualize only trips generated, we won't know in the map where they go, because are generated from the same zone, but basically we are losing the information where they go. We are just simply sum up all the elements in a row to calculate a single number, and basically we will lose this information. The same happens in the visualization of the incoming journeys. We know how many people, how many trips a certain zone will attract, but we won't know in our map where do they come from. Okay? Is it clear? So with these two visualizations, we are missing something, but there's a third, more advanced visualization that allows us to visualize exactly numbers, so origin, destination, trips, in order to understand how people exactly behave. What is the intention of people to move from their origin to their destination? These maps are called desire lines maps. Okay? And I will show you how to deal with these maps. So, let's recap a little bit. In order to visualize the odimetrics, we are going to perform three different visualizations. On the one side, outgoing journeys, trips generated. On the other side, incoming journeys, trips attracted. Third, last but not least, the desired line maps. So visualizing specifically all the relation in the odimetric and all the numbers stored in the odimetrics. Let's start with the first one. I've anticipated to you that I have to perform a visualization, a classified display related to something. For the outgoing journeys, so trips generated, I have to perform a classified display related to a certain attributes. Okay, so first, let me go back to the zoning to clean a little bit the visualization. I have to perform a classified display, right click over here, edit graphic parameters, and once again classified display. Now here, before moving to redefine all classes, etc., what I have to do is that of define the attribute that I want to visualize. I want to visualize outgoing journeys. I want to visualize generated trip by a certain zone that are basically the summation of all the elements in a row, as we recalled. So, what is, according to you, the element that we have to search in PDVs? With not too much fantasy, even the fact that I have to sum up all the elements in a row of the OD matrix to calculate trips generated, visum call this attribute matrix row sum. Matrix row sum. Here the point is, apart from matrix row sum, visum asks you, well, but what is the reference OD matrix? We have only one OD matrix uploaded, so if you click on plus, you will be able to select the matrix row sum related to our car OD matrix. Double click, and once you have selected it, just simply click on OK. Okay, matrix row sum, 100 car. 100 car is not 100, the number of 100 car, but it's the name of the OD matrix. It is stored in PDV visum in this way. Okay? Once you have selected the element, what you have to do is exactly the same things we did before for all the classified display. We have to first redefine all classes. Let's assume I have 4 classes here, and let's assume I want to use a natural break algorithm. No decimal places, because I'm not interested in decimal places, etc., etc. And then, for sake of readability of the map, I will start rounding a little bit these numbers that are calculated to the natural break algorithm. So the first one is 500, the second one is 1000, the second one is 2200, and I will use another color that could be the same we used before, okay? Even though you are reducing something, you're not following exactly all the steps. Bear in mind that if you will need to perform exactly the same visualization, first, you have the graphic parameters uploaded on the Weebit channel. Second, you have the recording of the lecture always available on the Weebit channel of the course. Third, you can just simply ask to me, okay? The thing that is important is, instead of giving you a sort of a flavor of what PDV visum is able to do and how to do all of this stuff, okay? Let's assume here I'm not interested in centroids, so visualizing centroids, so I can put all the sides related to text to 0 in order to let them disappear, given the fact that I'm not interested. Let's see on the preview. Okay, I've got the preview. It can, and I will click on OK. Before uploading the graphic parameter related to outgoing journeys in the Weebit channel, this is just a few comments. even though it seems really similar to population distribution, the meaning is completely different. We are performing an outgoing journey map, so matrix row sum, okay? And you will find it in the legend. So, also for sake of visualization, just simply feel free to modify a little bit the colors in order not to let the population density map appear like the outgoing journey map. I have also the outgoing journey map here with a different visualization, and I will upload it to the Wiki channel. I will also upload, because it's exactly, I will also upload, because it's exactly the same process in order to visualize it, the incoming journey maps. Okay, so now you should have also the outgoing journeys and the incoming journeys. Once again, outgoing journeys, trips generated by a specific zone. Incoming journeys, trips attracted from a certain zone. To visualize the outgoing journeys, we have to select the attribute matrix row sum. Instead, for incoming journeys, you have to select, with not too much fantasy, the attribute matrix column sum. Okay? Is it good? All good and all clear? If it is okay, I will pass to the last visualization related to the demand. And then at the end, in the third block, after the break, the final break, we will explore also the transportation supply. The third map, that is the most relevant one, because allows me to visualize specifically all the cells in the OD matrix in a map, is the so-called desired line maps. So, after performing outgoing, after visualizing incoming, you will see the graphic parameter is a little bit different also in terms of color. We will perform a desired line maps, starting from the zoning. So, we are erasing something, and we will start performing the desired line maps. How to do the desired line maps? You have to move to another functionality of PDD visum, that is the so-called OD pairs. Every time you move to something new, and every time you want to visualize something new, you have to do two things. First one, activate the icon. This icon over here. Second one, activate the text, the second icon, and from there you can start customizing things. Okay? First, right-click. If you want to customize things from the graphical viewpoint, because we are dealing with the representation, just simply refer to the object, in this case, OD pairs, right-click and edit graphic parameters. It's always the same process. No matter the object, no matter if you are dealing with zones, links, nodes, etc., just simply activate the object, right-click, and edit graphic parameters. Okay? Now, in this visualization, I have to select what I want to visualize with desired lines. Particularly, I want to visualize the attribute over here that has been already selected, that is the matrix value. So before, for outgoing and incomings, we were selecting matrix row sum or matrix column sum. In this case, we are not performing any calculation. We are just simply selecting the matrix value, okay? Matrix value related to our matrix, that is our car matrix, a matrix containing trips by car from origin and destination. We can select the attributes we want to visualize here. If you are interested, you can visualize more than one attribute. But in this case, we are not interested in that. So simply select the second one and click delete. Okay? Now, I will not focus on that. I won't spend time on that. This is just to say, there you can scale the maximum and minimum number dimension. All the visualization parameters are available to be customized, etc., etc. If you don't like the orange, just simply go on that and customize the color. If you want, instead of performing a uniform display, as in this case, you can also move to a classified mode, customizing also the color, meaning that I would love to visualize relations that are more relevant with the dark blue, and those that are less relevant in terms of exchanges, in terms of trips from each origin and destination in light blue, etc., etc. You will have the chance to customize everything, okay? To me, the most important thing is that of interpreting the results, having a good map that allow me to interpret the results. Bear in mind that most of the students usually experience a sort of a problem. We have a matrix containing 71 rows and 71 columns, so the final number of desired lines, of bars we are going to display will be 71 times 71. A very huge number, okay? Usually, PDV visum allows you to establish a certain threshold in order to visualize only the most relevant one. Otherwise, the map will be ineffective in terms of communication. Every time you have to select the number of desired lines to be displayed, you have to go on the desired line button over here. If you click on it, a new window will appear. Then look at the last box. Apart from layer control, general settings, text format that are all customizable, the last one is OD pair selection. And here you're able to display the most relevant, according to your threshold, OD pairs, origin-destination connection, origin-destination trips. By default, you will have 50, and here it is the map, really simplified. You can insert, instead of 50, 150. And let's do a preview to see how the map will look like. But we can also have 500. And let's see how the map looks like for 2000. And of course, the map will be impossible to be read. Okay? Now, here you have to find a good balance between colors, scale, threshold related to the number of OD pairs to be visualized, etc., in order to perform a good visualization that allows you to communicate something. The something that we want to communicate is, given our OD metrics, we will be able to communicate what are visually the relations in our study area, the most relevant relation in our study area. Now, as said, I did this exercise for you last evening, and I will upload it to the Wiki channel, of course. So the work in this case, that of course can be improved, I have to be honest, has been done by myself, but bear in mind that this visualization is very case specific, meaning that it's strictly dependent on the OD matrix, it's strictly dependent on the structure of the city, it's strictly dependent on the case study, okay? So you don't have to think about the fact, well, Francesco uploaded me on the WebIP channel the graphic parameter file. I will use for my transportation, project work on transportation planning, then I will use for other courses, and then I will use for my entire life. No, you have to customize the visualization depending on the project, depending on the context, etc., etc. Now, I've uploaded it on the WebIP, and I will show you how the final result looks like. As said, it can be improved, it's not perfect, etc., etc., and I'm sure you will be able to visualize something more effective with respect to the thing that I did, okay? One thing that I want to recall is that every time you insert a new object, in this case, we are dealing with OD pairs. If you want this object to be inserted in the legend, you have to go to the Edit Legend button that once again is over here. Edit Legend button. Okay? Now, before the break, let's move to the interpretation of our OD matrix. We started from an OD matrix by card, that is this one, a matrix of numbers that cannot be communicated to anyone. This could be a good way of communicating only with technical bodies, with engineers doing technical stuff. You won't be able to communicate this to a policymaker, a politician, etc., etc. You have to communicate things once again in a more effective manner. So we started from that and we arrived to this visualization that, even though it's not perfect, it's a little bit better with respect to the matrix we are referring to. This is our study area, as highlighted in the legend. So in light orange, we have our study area, and we have the desired lines. The darker they are, the more relevant the relation between certain origin-destination pair is. So, does anybody of you want to start with the interpretation of this map? I think that there are at least three things to be highlighted. So, I need 3 people, each one highlighting one of them. Please.
Bits of the lines are dedicated to the, I think, velocity or density.
So what you
The higher the number of travels between two lines.
Yes, it's good. So the higher the number of travel, the more the line is. Yes, it's correct. This is the technical interpretation of design lines, but I would love to some more qualitative interpretation related to our case study. Starting from that. So starting from the technical meaning of design lines, I would love to have some insights related to my case study. Please.
We can appreciate that the
Only one.
congestion is clear in the center zone. As we can see, mostly all the trips are from or that origin destination finish in the center and with a high value.
Okay, there's something that I like and something that I don't like with respect to your answer. The things that I like is that there's a strong connection here, something in the city center, okay? And we can only say that given the strong relation, as we preliminarily expected, well, from here to here, from left to right, there are some people living here, going here for working purposes, etc., etc. What we can say is that there's a strong relation that, of course, can affect congestion, but we don't know anything about congestion because we will discover the impact of congestion and on-road congestion only after demand-supply interaction. For now, we are focusing only on the demand box. So what we can say is that we can expect that after performing a demand-supply interaction, we can expect this section really congested by movements, by trips, starting here and arriving here, or vice versa. Okay? This could be one possible interpretation. Other 2 volunteers. I can anticipate that these 2 volunteers will interpret this map and will say more or less exactly the same things.
Yes, we can say that there are many cars passing through the city, not stopping in the city, but just passing through.
Yes, exactly. So there are many cars that starts from here, that is an external centroid representing a sort of an external area, passing through our study area, not being interested at all in the opportunities, in the work opportunities, in retails, etc., or in doing activities in our study area, but they use our study area only for crossing purposes. They pass through this way, maybe they will start from here and they will pass from here, or they will start from here and they will pass from over here. Actually, we don't know. We will be able to understand what are the roads they will choose only after the demand-supply interaction process. But what we can say is that there are some people starting from here and going there, starting from southwest and going to northeast, and vice versa. The same happened, I think I will need a 3rd volunteer, the same happened for this design line. We have several people that they are not too much interested in our case study, in our city, but that possibly will impact on the congestion of our city because they will use the city for crossing purposes, okay? So this is exactly how to interpret the design line map. One thing that I want to stress is that this has nothing to deal with congestion, it's just examining relation. okay? But from that, we can preliminarily expect something related to the demand-supply interaction, and so to the congestion pattern. As, you please recall me your name.
Yeah.
As Diego said, what we can expect, this is something that we have to prove, and we won't prove it today, but we will prove it after studying assignment models with Professor Coppola, that this block over here, this part over here, these roads insisting over here, could be affected by congestion. Let's see, okay? I will propose you a last 15 minutes break, and then we will start again at 1:05, okay? Thank you, guys. Okay. It's actually recording once again. Okay, I think we can restart with the last block of our lecture for today. Just to recap, we have first performed together a socioeconomic and territorial analysis. Second, we have analyzed the OD metrics, and so we have analyzed the demand. Specifically, we have analyzed the demand through the outgoing journey maps, incoming journey maps, and the desire line maps. And we will move now to the last block, that is the block related to the supply. Now, I will start from scratch, from my study area. I've selected the study area GPA, the graphic parameter related to my study area. And I have to start from scratch regarding my transportation supply. Now, the first thing that I have to do when defining transportation supply is that of representing it topologically. What does topologically mean? Means that I have to insert nodes and links, okay? I've done it for you, but we have to activate the visualization of both nodes and links. If you switch on the icon related to link, well, you will see that a link road network will appear on the PDV visum version. Bear in mind, you have in real projects the possibility of designing everything on your own, or extract the database of links and roads from official or unofficial sources, for instance, OpenStreetMap, and upload it automatically in PDV visum, okay? Apart from links that are directed segment from nodes to nodes, well, the base step was that of defining nodes, and I've defined nodes also here. Just simply switch off the nodes to be visualized. Now, if you want to visualize a graph in a more efficient way, instead of designing nodes as cross, you can simply right-click on the nodes element, edit graphic parameter, and as we did exactly for zones, zone numbers, zones values, zones attributes, etc., etc., you are able to customize the visualization. Instead of cross, let's assume we want circles. Regarding the size, let's point it equal to 2. And regarding the color, let's assume it is a green instead of something else. I will put also a little bit of border. Let's assume the border is blue. I don't know. You have to feel free to customize in the way you want. Just simply click on preview and click on OK. Bear in mind Once again, the visualization is exactly, the visualization view and command is exactly the same for all the objects you have in PDD visum. So every time you want to customize an object, just simply refer to that object, right-click, edit graphic parameter, and then start exploring a little bit the visualization. Here it is. Not so effective, probably, but this is my view. I will tell you also a small trick, at least for those of you that are, I would say, visualization maniac and want to customize things and optimize visualization in the most efficient way possible. Well, according to me, a good way here, in order to visualize things better, could be, apart from inserting in the legend nodes and links, could be that of having different layers. The base layer, my steady area, then a layer related to nodes, and then a layer related to links. Because otherwise, if I put the node layer on top, some links are quite hidden and won't be possible to see them. How to do that? In case you want to do, it's not mandatory, but for effective communication, according to me, it's a bit mandatory. Just simply go over here, not the edit legend button, but the button at its right, that is edit graphic layer. Clicking on this button, you will have all the layers, those active and those not active, and you will be able to redefine an order. In particular, in this case, I would love to have links on the top, so I will select link, and I will use the arrows to move it on the top. Okay? On the top means at least up to nodes. Okay? Just simply click on preview, click on OK, and here it is. I don't know if it is better or not, but at least it's a way to explore an additional command in order to customize effectively the visualization. Now, I have created also this transportation graph. I've used different colors last evening, and I will upload exactly the same GPA, graphic parameter file, in the WebIP folder. So you will have the chance to start exactly from my same graphic parameter. Simone.
Understand the last task.
Do I have to repeat the last step?
The icon that you press.
Okay. One thing that you have to press if you want to visualize nodes and links, you have to activate the icon related to node and link. You have to switch off both. Yes. Yes. Okay. The second thing is, if you want to redefine an order of layer, because here you have several objects, right? In particular, links and nodes. And let's assume you want to visualize nodes, links at the top, and then nodes in your two-dimensional view, okay? How to redefine this order? You have to go to the button that is at the right of the Edit Legend button. The button is called Edit Graphic Parameter. From there, you will be able to select the layer that should be on the top, according to your visualization idea, and to move it on the top, this layer, or moving the others at the bottom using arrows over here. Okay? Okay, so this is my transportation graph. Now, the transportation graph is a topological representation of the network, okay? So every time we talk about transportation graph, we used to refer to the transportation graph to something, I would say, not animated, because basically it's a list of nodes connected by direct links, okay? How to animate a little bit more this graph? A way to animate this graph, because our ambition is representing a transportation network, so bear in mind the distinction between transportation graph and transportation network, is that of associating to each node or each link, in this case links, some attributes. What are the attributes that could be relevant to be associated to links representing road network? Could you please give me some examples? I've schematized the topological representation of my roads, okay? But basically roads that I have in a city, roads that I have in reality are not all equals, are not homogeneous. There's still a variability, a difference between roads and roads, depending on, just give me some examples. The number of lanes, right. And bear in mind that the number of lanes, of course, affect the capacity of a certain link. So the maximum number of vehicles that can pass through this link in a certain hour without being much disturbed by other vehicles. And of course, the number of lanes could be, together with the capacity of a link, an attribute to be inserted in a simulation tool. Yeah.
The category of the road.
The category of the road. We could have, for instance, main road, primary road, but also secondary roads, and also local roads. Okay? Next. Speed limits, that could be. Also, speed limits on the one side. Sorry?
And speed design. Speed velocity.
Speed design, okay. Yes, but you have to have in mind that you have to always put yourself in the brain of a potential user. If I put speed limit to certain roads, in a way I'm constraining roads to be passed at a certain speed. But in reality, there are people that move faster with respect to that speed. So a good velocity to be inserted, of course we can insert also speed limits, but a good velocity to be inserted could be a sort of a desired velocity, a sort of so-called V0, that is the velocity when the road is empty. A velocity to which, on average, people will pass this road where the road is completely empty. This is the velocity that we usually insert to define link attributes, okay? There are several other attributes that could be inserted. One attribute could be also the cost function of that specific link. In particularly, in congested network, you've seen with Professor Coppola, do you remember the so-called BPR function? A function that allows you to represent the travel time or the velocity on the vertical axis, depending on the flow on a certain link, representing the fact that when roads are quite empty, the travel time is a certain value. when roads are congested, where the flow will increase with respect to the capacity, and where the saturation, the congestion rate is higher, of course, the travel time will be affected and the travel time will be higher. These are other possible attributes to be associated to our topological representation of the network. So from now, we have transportation graph. If we are able to associate to this transportation graph some attributes, such as lanes, capacity, velocity, cost function, volume delay function called in PTD visum, etc., we will move to a transportation network. One thing that I would love you to notice is the fact that if you zoom in a little bit, you will find some links that are modeled in our modeling tool, so in my model, some others instead, and you will be able to highlight them from the background map, that in reality exist, but are not modeled in a modeling tool. Why? Because you have to always have in mind the coherence between zoning and the granularity of the zoning and the road network. This is a base element that you have to always have in mind, okay? This selection, the identification of the base network, has been done in this case in this way because it's coherent in terms of spatial granularity with respect to the zoning. You cannot have a very detailed zoning and a poorly detailed transportation network, or the other way around, a very detailed transportation network and not too much detailed zoning level. So we assume that in our final simulation, these roads that are not selected are more local roads that could be relevant, for instance, for intra-zonal trips that we are not simulating. Okay? Is it clear? Good. Now, we have more or less 20 minutes, half an hour, to pass from a road network, so from a transportation graph to a transportation network. But before doing that, I would love to show you, for sake of completeness, how to add new objects in PDD visum. Because you may say, well, you gave it to us, but we don't know how to, I don't know, add new links, add new nodes, etc., etc. Well, the two buttons you have to have in mind are these two here, the plus and the arrow. In the editing phase of a model, it's a sort of a tango between plus adding new things and the arrow, select new things that you have added and modify them a little bit, okay? Every time you want to add something in your model, what you have to do is just simply go on the selection of the object you want to insert. Let's assume I want to insert nodes, so I have selected the nodes functionality. I will go through the insert mode over here, so clicking on plus, and I will start adding some nodes, 1 and 2. Okay? Then, after adding new nodes, that could be, this is just an example, okay? You will move to the edit button, to the arrow, to deactivate the functionality related to the add something, to the insert something, the insert modality, okay? Now, in my very, very trivial example, I've had the two nodes. I'm not going to save this example, this VR file. This is just an example of two additional nodes. The point is if you want to add new links, just simply go on links, move to the insert mode, and then you have to select the origin node and destination node. If you insert a new link here from the origin node to destination node, a new window will appear and will ask you for some specification related to the link, some attributes related to the link. For now, let's not consider this. This was just an example, so please do not click on detail, OK, sorry, click on cancel. And if you want, you can also delete the nodes you've previously drawn and insert. Okay? This is just for you to say, if you want to add something, first, select the object you want to add. Second, click on insert mode, and then start playing, start doing this sort of a tango between insert mode and edit mode. Okay?
It's important to take in consideration the direction of the vector.
Yes.
In that case,
Every time you add a new link, for instance, you add it from the origin node to the destination, and that would be the direction. Once you will be called to define the characteristics, you will be able to define also the characteristics of the opposite direction. And you can choose to close the opposite direction in case of a single lane link going only from north to south, for instance, or to establish the same characteristics, to define the same characteristics for both directions. I mean, there are both possibilities.
and I think it's possible. Are we able to create, to display the direction of the links in order to review that is the code?
Yeah. But still, there's also the possibility to display the link direction.
Okay.
And every time you will, activating links, you will be able to select links. If you pass through a certain link, you will be able to see what is the direction of this specific link. Okay? Just simply passing through, and in some cases are single direction, some cases both direction, etc., etc. This is a very simplified model, just for sake of training, just for sake of an example. Okay, but going back, our objective was, and we have less time than before. Our objective was that of moving from a transportation graph to a transportation network. The difference is, in transportation graph, I have only nodes and links. In a transportation network, I have nodes, links, plus attributes. And I have to define attributes. Now, attributes has been defined by myself for each specific link. How to see which attributes have been defined? You have to just simply go to the database related to links. Okay? So, for each link, you can double-click to explore its characteristics. If you select one link, you can double-click and explore these characteristics. Of course, you have to have the links button activated. Or, in case you are interested not in a specific link, but in all the links included in your model, you can go through the database of links, that is, the list of links. As we did before for zones, just simply go on list, network, links. Every time you want to explore something related to certain objects, you have to go to list, network in this case, and the specific object in which you are interested. I'm interested in links. If you click on that, you will be able to see the list of links. Okay? Now, in rows, you have links, directed links from an origin node to a destination node. Bear in mind that here, in this case, if you look at link number 5, you have modeled both directions. This one from node 155 to node, I don't know, more than 10,000. And this other one, the second row, is exactly the opposite. You have modeled the so-called type number, and we will see what is the type number. We have modeled the transportation system that is able to pass to this link. In our case, in our simplified model, only car. We have link length, we have number of lanes, we have the capacity, and we have the so-called V0, the velocity at free flow speed for private transport, in our case, for cars. Okay? Now, you can imagine on your own that in reality that there are several links. Each link has a specific attributes. So, if you are a crazy modeler, you can spend 1 month defining specifically each attribute related to each link. Instead, if you are a smart modeler, you can define classes of links with homogeneous attributes to be defined in your model. Okay? This is what I did in this case. So I have preliminarily defined some link classes, and then when defining new links, when inserting new links, I have specified to which class these links belongs to. And so visum is able to understand on its own what is the number of lanes, what is the capacity, what is the free flow velocity, etc., etc. What is the transportation system, etc., etc. If you want to understand what are the classes of links that are included in your model, you have to go to the so-called link types. Link types that you can find in list, network, link types. Once again, list, network, link types. So, once again, list, network, link types. When examining before the list of all the links included in my model, so more or less 3,000 links, we've said that, well, there's also an attribute called type number that is associated to something, but we don't know what this something is. Well, the type number refers to the link type, so to the class of links to which these two links belongs to. And if you go on the link type list, you will see the number, that is basically the type number from 0 to 3, and all the characteristics. Particularly, we have inserted 4 classes of link. We have made a preliminary analysis of the supply of our study area, the transportation, road transportation supply of the study area, and we have defined 4 clusters. The first one, we called it main double lane. The second one, main single lane, primary and secondary. Okay? These are the classes of roads we have in our model. And to each class, we have defined some attributes, such as transportation system type that is able to pass to that specific link, car for all, the number of lanes, 2 for the first class and 1 for the others, we have defined the capacity, we have defined the free flow speed, the V0, the maximum speed, etc., etc., all these attributes, including an attribute that's so-called VDF number. Now, this VDF number is related to the so-called link cost function. In visum, and this is I think this is probably the only semantic difference from the theory to what visum implements, the only semantic difference, the link cost function in visum are called volume delay function. This is the only difference. So the VDF volume delay function. Is it clear? All good? Okay. For sake of completeness, I will show you where the volume delay functions are. You have to go on calculate over here between filters and graphics to general procedure settings. You have to open the PRT, the private transport settings, and you will be able to find the so-called links VD volume delay functions. In our simplified model, we have 3 different volume delay functions. In case of main road, no matter if it is double or single lane, we have volume delay function 3, 2 for primary, and 1 for secondary roads. If you want to understand what is the volume delay function, so the link cost function from the mathematical viewpoint, what you have to do is just simply double-click in the bottom part and see what is the mathematical formulation. As said, the mathematical formulation, you will be able to find several formulations. This is a normal BPR with some parameters inserted, and basically you will be able to understand on your own that is a function of the travel time, the real travel time on a certain link is a function of the travel time when the road is empty, that is the travel time at the free flow velocity at V0, the so-called T0, multiplied by 1, of course, plus an additional member, an additional value that is dependent on the flow divided by the capacity of that specific link. Okay? If you are not familiar with volume delay function, don't worry. This is just for you to say, well, you have to specify all of this stuff. And bear in mind, all of this stuff in a model should be calibrated and estimated starting from data. So you don't have only to estimate the 4-step model related to the demand. Emission, generation, distribution, mode choice, and path choice. You have also to estimate all of these variables. So the process of creating a good model, a realistic model, could be very, very complex and sometimes also data demanding. We are not covering too much in this course modeling estimation. This will be subject for next year for the sustainable mobility behavior and policy course. Okay, we have covered everything, but what I said is I have a transportation graph. I have associated to links some attributes velocity, class characteristics, so link types, volume delay function, etc., etc., etc. What I would love to do is that of visualizing in a good way the transportation graph. So, till now, I have visualized only the transportation the transportation graph. I have to visualize in an efficient way the transportation network, just to have a sort of a qualitative flavor of what are the type of roads to be included in my model. Okay? How to do that? I'm referring to links. I want to visualize something related to links. For instance, the link type of each link. Right click, once again, graphic parameters, display, edit graphic parameters. In this case, I'm not going to perform a uniform display, but rather, similarly to what we did for zone, a classified display taking into consideration the road type that I have. So main double lane, main single lane, primary or secondary. So a classified display considering the type number. Okay? Classified display, then click on the pencil to select the object, the value to which you want to classify, and then select type number. Okay? If you then click on OK, you should see something like this automatically. Clicking on preview, you will obtain this visualization. Okay, also this visualization is not too much optimized. I've done it last evening for you. My transportation network, a little bit better, probably it could be improved, but at least a little bit better, okay? And I will upload this graphic parameter on the Weebit channel of the course. Now, to recap, we have analyzed the current situation regarding the two socioeconomic variables, so context analysis and territorial analysis, etc. We have analyzed the demand, and then in the last part, we have analyzed the supply, particularly focusing on the one side on the transportation graph. Then we associated some attributes to link, and we moved to a visualization related to our transportation network. That will be the basis for all the next step in analysis. So we started from our study area. We subdivide the study area into different zones. Each zone has its own centroid. We have then identified our basic network. This is a sort of a three-dimensional visualization. Please excuse me, it is not optimized. Let's do it this way. We have then defined our network that is composed by nodes and directed links, okay? Here, the demand, in a way, in these fictitious nodes is stored through the OD metrics. So here there are some trips by car ready to start and ready to travel. And particularly, they are ready to use our transportation network that we have identified. But from the mathematical viewpoint and from the modeling viewpoint, there's something missing. What is missing? I have two different layers not talking with each other. So here, there's the demand stored through the OD matrix, ready to start from origin to arrive to certain destination using the road network. But the demand stored in these fictitious nodes, centroids, how can reach the destination? By routes? By routes, yes, but these are not interconnected. There's something missing.
We need to associate each area to each link and nodes.
Yes, we have to, in a way, in very simple word, we have to connect these fictitious nodes, centroids, to my transportation supply. And how? We have to connect centroid to transportation supply. We have to connect centroids to transportation supply. I will repeat it for the third time. We have to connect centroids to transportation supply. We have to connect centroids to transportation supply through connectors. Otherwise, these two, I would say, macro layer won't communicate at all. We have to connect each centroid with a fictitious link through my transportation supply. The same for all the centroids. Otherwise, I'm not able to model anything. I'm not able to perform this so-called demand-supply interaction, okay? How to do that in visum? Just simply go to centroid and start adding them. I have the final visualization already performed. So, starting from each centroid, no matter if it is internal or external, and having considered my transportation supply, so nodes and links, I have connected this centroid to my transportation supply through connectors that are the arrows that you will find in orange in my visualization. I will upload this also to the Weebit channel. This is just to say, if no matter all the good analysis that you did in the beginning related study area, no matter all the good analysis you did related to the demand, and also the analysis and the way of modeling the supply, if you do not insert connectors, you are not able to simulate anything, okay? One thing that I would love to show you is also the fact that in very simplistic terms, you need at least one connector per each centroid, at least. But in models, we will usually use to insert more than one connector, okay? The reason why we do that is for simulation purposes. and you won't be too much aware of the importance of this stuff if you not practice a lot with modeling. This fall, I would say, within the sphere of the so-called art of modeling. The point here is, if you see a model with one centroid connected with more than one connectors, you don't have to be scared. It's something normal. It can be connected by one or by more than one, but at least one. Okay? I think that's all for today. I would love to hear your voices in case you have questions, curiosities, or stuff like that. Please.
How the centroid distribute the load of the, for example, the population had to come to another centroid?
Depending.
There are 3 arrows, 3 connections equally distributed, or I don't know.
Yes, it depends on the rules that you will define. But generally, if you insert more than one connector, you have to have in mind that it's not the population that is distributed. It's the number of trips included in the DOD matrix. Now, let's assume this centroid over here, okay? Sorry, this centroid over here is not this centroid over here that is connected to the network through 3 different connectors, okay? Now, depending on the assignment, demand-supply interaction, and depending on the demand stored in this centroid will be distributed. Of course, you can imagine that most of the demand that have to go from zone 770 to a zone over here 410 will use this connector, and these other ones will use will be distributed to this one. But these are fictitious things, okay, that you have to simulate and you have to define the best way possible. How they are distributed would be then, it's not something that you can say, apart from very rare cases in which you establish rules, it's not something that you can say a priori. You have to say ex post after performing a demand-supply interaction, and then you will understand how it is. One thing that is worth to mention is that apart from this situation where you define the position and the allocation of these connectors, connectors can be modified if, after performing the supply-demand interaction, you judge it as not realistic with respect to the real data you have, okay? In that case, you can also evaluate to go back and modify something, because every model creation is a sort of an iterative process, okay? Other question, guys, with respect to everything we've covered till now? Guys, very, very basic things, but definitely important for the following weeks of the course. Please, Daniel.
Or
The centroids, you mean? Sorry, the connectors, you mean? Okay, you can choose to do it manually, or you can establish rules. Yes, if you right-click on Create, if you select connectors and right-click on Create, there you will be able to define rules, maximum length, distance, how many connectors should be defined, etc., etc. There's a process to automatically generate them at the first glance. Guys, please, other questions? No. One very, very minor thing. I've received from, I suppose, most all of you, the preferences regarding your project work. The preferences regarding your groups. I've stored all of them, and I think I've answered all of you regarding groups, not regarding the activation and license activation of PDB visum, but I will do it soon. One thing that I want to say is that the final group list will be uploaded to the WeBeat channel, and I will also create for you Microsoft Team chats, adding all group members that will be useful to communicate with me, with your tutor, etc., etc. Once the project work on transportation planning will be presented, will be assigned to you, and will start. Okay? So the final group list will be uploaded to the WeBeat channel soon. For those that communicated to me, well, I don't have a group, please assign me to a group, you will find the final group list and your group mates through the WeBeat channel of the course in this or next week. Okay? Thank you, guys.